Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are doing some work on our multi-plane rendering sort of Z situation. As everyone probably who's ever written a 2D game knows, there are certain concessions you have to make in a 2D game because you're inherently sort of trying to present something that usually has some amount of depth to it, but that depth is obviously not quite real because all the illustrations are 2D and you don't really rotate, and there's other things like this. And what we found on Handmade Hero through experimentation and basically building a bunch of stuff that we wanted to build and testing how it worked and that sort of thing, is that we have a pretty solid idea at this point of how we want depth to work in the game, and it requires a slight modification to how we submit things to the renderer to finally sort of solidify what it means in the world to have depth. And so what I did yesterday was I created sort of a example layered scene that sort of exhibits all of the problems that we have with Z right now so that we can go through and if you'll pardon the pun, sort them out and make it so that we can be relatively confident that the interface to the rendering layer accurately represents a convenient and correct way for the game to specify what it wants to do with respect to depth. So let's take a quick look at where we were with that. Again, this is day 296, if you missed the little bar at the beginning. So day 295 source code is the source code that you want to work with today if you're trying to follow along at home. So here is the source as we left it. There we go. And you can kind of see here how we've got a couple things. Even right off the bat, you can see that there's a couple things that are a little bit wonky. One is our sorting is kind of broken, and that's kind of a consequence of the fact that we aren't currently doing certain Z things the way that we should. Now, it's not really, this makes it look worse than it actually is. The reason for that is that currently there's no way to say that something is flat or not flat. This kind of gets back to an old thing that we did in the renderer where we were saying, oh, there are things that are lying flat in the world, and then there are things that are sort of upright, and these are two sort of different kinds of surfaces. And the way that sorting has to work has to be different between these surfaces, and that is something that we hadn't really addressed yet. So there's that is what's actually happening here with the rectangles that are being drawn as the squares that I'm jumping on, sorting in front of some of the character sprites. That's what's happening there, effectively, is rectangles. We never bothered to set that path. Now, you know, I could be wrong about this, but I think, and let me just double check, I'm not actually sure about this, so let's just take a quick look here. I think it's possible that that was actually something that when we put it in there, it might be actually something you can turn on for anything, not just bitmaps. The fact that something's kind of lying down, and that's in the object transform. We've got this sort of upright situation, and you can see that inside world mode, we had been setting it, I believe, for things like world chunks. I guess it's not there at the moment, but we certainly weren't setting it for things like these traversables, and I probably should. So what I could do there is take entity transform, for example, which is what we were doing for this object transform. I could take that, and when we go to start drawing like these volumes and traversables, I could right here say entity transform upright equals false. And so you can kind of see the difference that makes, right? Like if I set that so that it's understood that those things are kind of lying flat down, you can see that makes sort of a substantive difference in how sorting actually behaves. But still, you can see that we've got other problems there that doesn't really fix. You can see that there's sorting problems here, for example, and other things like that. And again, these are not bugs in the sorting. The sorting is working exactly as it should. They're bugs in our ability to specify what's supposed to be where. Because what's supposed to be, the order that things are supposed to be drawn is very easy to specify if it's always constant, but it makes things more difficult when it's a little bit more flexible and can change, such as things like this, stairwell where I'm kind of going up gradually and things are getting pushed back into the distance, and I'm under the floor now, but I'm going to be above the floor in a second, and there's kind of all these little edge cases in there and stuff like that. So anyway, point being, we've got some stuff to address there, and the much more major thing that we have to address is the fact that Z is currently doesn't actually do displacement. Z is currently ignored for displacements where you have, say, a character whose head is like bobbing up above the ground or whatever. We would want to use something like the head bobbing above the ground. We would want that to be a Z displacement because it is actually a height thing. But right now, displacements in Z don't do anything. They literally only affect the sort order. They don't actually change the position at all. And so what I would like to do there is I would like to fix that so that we do have the ability for Z to hover. And furthermore, we do also want the ability for Z to represent things like perspective changes, as in the case that you're seeing here where I kind of can go up and down these floors. We actually want that to keep working, but the important part there to remember is we want that to occur specifically for floors and floors only. And I don't mean for the actual floor tiles. I mean for a whole chunk of the floor at a time, like a whole basically room. We want that whole thing to go down or up as one sort of coherent piece. We don't want like what's happening right now with the stairwell, right? And the reason we don't want things like the stairwell is simply because our art is an orthographic projection. And it really wreaks havoc, we found, with the player's sort of sense of what's going on when you have some things operating in perspective and some things operating not in perspective. And so what we kind of want to do is avoid that problem by sort of leaving everything on one floor in a way that is, in a state that is highly orthographic and is always going to continue to have that orthographic sort of style to it without any perspective shift. And then only when you kind of move a whole floor up will you see the entire floor below you get, shrunk down, and the floors above will kind of come in that standard perspective way. Furthermore, we have sort of this notion that we've got sort of faraway floors, and you can see those kind of, at the moment, sort of fogging out there. We would like the notion that floors above us alpha in as they come down, like they are currently, only we'd probably like to do a better job at that eventually. But those faraway floors, we don't want to alpha. We want to fog them out, not alpha them out, because they don't get transparent. Like, we don't start seeing through them when they're there. Instead, they just kind of become dimmer and sort of like give it some kind of a little bit of a haze effect so that you can kind of get this feeling that there was like participating media there or something that's making it harder to see, right? So that's, kind of the whole situation with Z. And so we need to go through and straighten out, first of all, how we are sending things down to the renderer so that it has a clear understanding of what we're trying to say in terms of the Z values of things and where they are. And then the other thing that we have to obviously do is go and actually sort of handle that Z in the renderer in the way that is most appropriate, right? So we got to add the ability, for example, to do that fogging and so forth, which we don't actually currently have. Now, it's worth noting that even though I don't know if global alpha was such a good idea, at the moment that's how we're kind of doing that fogging, and we'll sort of see if that holds up, but something similar to it is going to occur. Like, we're going to want to set sort of a global understanding. What I'm thinking here is that if global alpha was instead of V4, that might also handle our fog problem. So instead of doing global alpha times color, where we're sort of reducing the color by that global alpha value. I'm thinking that what we could do there is sort of do a an effect where we multiply the whole color, that whole global alpha, right? And this would be maybe like global modulate or something like that, right? We'd multiply that against the entire color. So we could change both the alpha value of things and, excuse me, in addition to the alpha value, we could change the color values as well. Now it's a little bit difficult to think through because one of the things that we haven't been particularly good about, and this is another thing that we probably want to do a little bit of a tidying pass on at some point, is we haven't been very good about specifying whether our color values are pre-multiplied alpha or non-pre-multiplied alpha, right? And so, when we say that this color value comes in here, well, is this color value pre-multiplied by alpha or is it not pre-multiplied by alpha? Because it makes a pretty big difference. And usually what the convention I like to use is that things are not pre-multiplied alpha. Alpha pre-multiply happens later is typically the way that I like to do that. And so if we go in and take a look at like how our bitmap rendering works, for example, or actually, we could take a look at our OpenGL, for example. So in here, if you take a look at what we do with color values, you can see that we just specify the color value directly. And since we're using pre-multiplied alpha everywhere else, I'm not sure that this is really correct, right? And similarly, if I go into, for example, our own renderer that we wrote ourselves, which I guess is just render.cpp, right? If we take a look at what happens inside, say, the draw rectangle quickly code, which is right here, I'm interested to see like what were we saying the convention was there. Yeah, so you can see us pre-multiply the color when it comes in here. So you can see that this is kind of a little bit wonky, right? And it seems to me that we should start taking this a little bit more seriously. And so why don't we try to fix this whole color path just in one go? So the first thing I'm going to do is, I'm not going to do the pre-multiplied alpha thing yet, although that's important for us to get right. So we're going to take a quick break from that, and I'm going to come right back to it. What I'm going to do here is say that when we specify render elements for entries, I'm going to do something here like, record color or something like this, right? So I can basically say, okay, I want to store a color value. This is the input color value. And, we don't really know what that's going to do quite yet. But we know that everywhere that we're going to pack color into an entry, we want to call this store color, right? So we pass the source, then we've got the destination color. And all I'm going to do right now is just pass it directly through, right? That's it. So now, if I went through here and I looked at every time that anyone did a push call and stored a color, right? You can kind of see here, right, we're pushing bitmaps there, so we can pass everything through and that'll happen. But then you can see when we push rect, well, we should do the same thing there. When we push rect outline, those will go through the same path, so that's fine. When we do a clear, we should do this here as well, right? And you can kind of see how now, at least now we've got everybody going through that one store color call. So now when we do store color, we could say, okay, the convention here is going to be that when we call store color, we're going to take the Handmade product of the source with the global. So we're going to need the render group. And we're going to say the group global modulate is going to multiply the source. Now remember, if you're unfamiliar with the Handmade product between two vectors is what you might call the most straightforward product that people who don't know linear algebra, don't care about linear algebra, might think was the most logical one even, right? We all, because we're graphics programmers, tend to think more about products that we use a lot, such as the inner product or the cross product, or even an outer product maybe. But The Hadamard product is just one where if you have X, Y, and Z, and you want to take, you know, the Hadamard product, I'm going to say this is, I don't know what the actual operator symbol is for Hadamard product, if there is one. If I'm going to take the Hadamard product between two things, I just get the multiplication by the components. So I'm literally just taking the corresponding elements of each. I should probably write those consistently, huh? XA, YB, ZC. I literally just write them as direct products of the things I'm multiplying. So it's like, hey, take the 0th element, multiply by the 0th element, first element by the first element, and so on. So that's the simplest kind of product, really. It's just one that we don't use very often. Really, color blending is the primary place you would use it. Let me see if is there an operator? There it is. So it looks like maybe a little open circle. Looks like a standard. So maybe we'll just so that's all we're going to do here, and that modulation would allow us to do fog effects now, as well as alpha blending, because what we can do is we can set this global modulate value to pull down our color values, right? Now, the problem with this is going to be we're going to want something a little bit fancier than this, because this will allow us to do fading out to like black, but if we wanted to fade out to more of a white color, that's not really going to work, right? So we kind of would need the concept of a fog value that we blend to, and you know, that's probably a little more flexible for our purposes. So the other thing we could do, obviously, is we could say, well, there's a global modulate, and then there's like a global sort of like a global color or something like this. And so what we could do is say, well, you know, we'll take the global color and we'll blend to the global color from wherever you are, and then we can also have a modulate, which is a thing which multiplies, right? So we could do sort of a linear blend as well as a modulate, right? And furthermore, we could do something where we'd say, oh, okay, maybe what we do is just each one of these values is the lerp for these. So it's more like T global color and global color. So here I can say, well, all right, the way that this works is for each element we're going to lerp, right? So we'll do something like, here's the dest, and the dest.x equals the source.x, and I'm going to go ahead and pull out the t value is group global, t global color, and the color value is going to be global color. And so then in here we can do each one of these is a lerp between whatever the source color is and how far we want to go towards that global color, right? So now, if we want to modulate, we actually can modulate by just setting C to 0 and T be the modulation value, but if we want to blend towards a color, we can also do that by setting the color value to something other than 0 and T being the amount that we should blend to it, right? And if we want to, we can also reverse the sense of these so that, that if we wanted it to be modulation, but I think I'm going to say instead of modulation, I'm going to actually make it be sort of the inverse of modulation, meaning the higher the value goes, the more you blend towards the color, because that way I can do a knit to 0. So meaning you initialize everything to 0, T global color will be all zeros and won't have any effect, which is, I think, maybe a little more consistent with the way I've been programming things. You know, I don't know if that'll work properly or not. We'll find out, but here we go. Oh, here we go. And you know what? These should really be RGBA, right? So that is all I really wanted to do was storing the color. So this way, every time we push a color on there, we just do a quick little bit of math op on it there. And then these things can be set by the game. So inside all of the stores, we just need to pass the group, which is not onerous because, you know, we always have that anytime that we were storing anything anyway. We don't have to initialize this anymore because it'll automatically get initialized to 0. So that's good. And anytime we're setting the global alpha here, you can see us setting the global alpha for each entity. And so in here, what I would say is, okay, we don't really need to set this quite the same way, but what I would say is we probably want to start by saying, well, let's see which of the 3 cases we're in. Because unlike before, where we were always fading, we're not fading anymore. We're fading on one side, or sorry, I should say we're not always fading. We're fading on one side, which is the stuff that comes down from the top, but we're fogging out below us, right? And just to be clear on what the difference between those two is, right? With something like a fade, we're actually talking about being able to see through it, right? So we're talking about, you know, if here's the eye point, right? And here's a layer, and here's a layer. What we're talking about here is, okay, we're going to be able to see through to this layer, and this thing right here will be at some percentage opacity, like 50% opacity or something like that. That's layers that are kind of in between the camera and where the player is standing. So those are actually going to have alpha fade in them, right? But then there's stuff that's like that we see through down to their lower levels of the dungeon. That stuff should never be transparent. You can never see through it, but it should get hazier, right? So what we want to do there is blend to a color so that we're sort of mixing away from the actual color of whatever the thing is towards a generic fog color, which would be like a dark, misty whatever, you know? All right. So we want to start by saying that in the normal case where we don't have any blending going on, the render group's global color is going to be, well, we don't care what it is. We just know that the T global color is going to be all zeros because we don't want to blend it to it at all. Then if we do either of these two, we can still keep the global alpha value concept here, like the T value that we computed. We can still use the computation we were using because it seemed to be okay. But what we want to do is now prep these other things a little bit more appropriately. So global color, in the case of fading out the bottom, is going to be our haze color, right? So, you know, I don't know what this should be. You know, maybe we'll set it to something like 0.5, 0.5, 0.5 or something like that. And our T global color is going to set how much of that we want to contribute. And we want all T's and then a 0. And the reason we want the 0 is we don't want to adjust the alpha value or anything, right? We just want to set those, we just want to blend the color. So this allows me to blend in the color here and not blend in the color in the alpha, and just leaves the alpha at whatever it is. In fact, I can nuke that as it, you know, that fourth parameter now will not have any effect. Similarly here, where I've got global color, I don't really care about what the color values are because I'm not really trying to change the color values. All I'm trying to do is change the alpha value so that it fades out. So this is exactly the opposite. Here I'm basically saying, you know, let's keep the T value, but let's zero out, let's keep the T value for the alpha, but let's zero it out for all the colors so that we don't affect the colors at all, right? So that's how we would set our alpha. And then down here where we're clearing it back out, we can just, again, set T global alpha equal to all zeros, and that will get rid of any blending that was going on. Whoops, global color. Now what you can see here is that we always use the same T value for color and alpha. So one thing I could do as well is just have, I'm sorry, I always use the same t value for all the colors, and then one t value particularly for the alphas, and they're always sort of one or the other. So we probably could be less flexible than this, but at the moment, I don't know that there's a whole lot of a reason for us not to be, but it's worth pointing out. Okay, so now we still have a lot of work to do because we're not quite, well, evidently we have a bug as well. But we're not quite handling the alpha multiplication stuff correctly yet either. So I'm going to have to go fix that in a number of other places. So first of all, let me just make sure that these things are at all correct. Like I said, we compute these t's. So for example, when we're fading out at fade top, we want to fade towards a 0 alpha value for whatever we're working with. And I believe that it was a bug in here, like I was saying in the OpenGL layer when I'm looking at it, that it wasn't pre-multiplying that. So if it's not going to pre-multiply that, and I think that, you know, looking at this, if we want to just set these colors down and not pre-multiply them typically, I think that's going to be a good idea. And I think what we should do is just do it in the pack function. So I think what we should do is come over here to the renderer, where we were doing that pre-multiplication. And you can see us pre-multiplying the color up front here where we do this pre-multiplication. I think what we're going to want to do is we're going to want to roll that pre-multiplication into the calling code. So we just don't pre-multiply things anymore pretty much ever, right? So I'm going to come in here and take that out. I'm going to take it out of the pre-multiply here and here. And we should probably also take a second here to label these things correctly as well. So in some of this stuff, when we record these values coming through, maybe I can go ahead and set them in render group so that it says specifically whether they're pre-multiplied or not. So for example, we've got clear. This is pre-multiplied clear. This is pre-multiplied. This is pre-multiplied, right? So it's just, and pre-multiplied clear doesn't really mean much of anything, but it's just so you know, hey, these values are always going to be pre-multiplied through the whole pipe from here on out, so get used to it, right? So let's go ahead and keep picking that up. So this is going to be pre-mul color, and when we do store color, what I'm going to do then is say, well, okay, when I'm producing this information, what I would need to do is once I have that alpha value, right, I now need to always multiply the color values by that so that the color values are always pre-multiplied, right? So here's my pre-mul color. Let's keep going. Here's my pre-mul color. Here it is. And now we've got to fix it in here as well. Pre-mul color. Oops. Pre-mul color, pre-mul color, pre-mul color. And in here, same deal. And again, you can see all these being used as pre-multiplied. Let me look at OpenGL rectangle. OpenGL rectangle color. So there's, yep, all good. And this is a pre-mul color as well. Might as well make that explicit. And so let's see. Color is not a member of, here we go. This is mostly just search and replace at this point. All right. So let's pop back now and see, because I'm sure we've got problems now to deal with, but I think that's a little bit more correct through the pipeline so that we can yeah, we can be a little bit clearer about where things are supposed to be pre-multiplied and where they're not. Let's also briefly make sure that our other renderer is working okay. So that definitely has a pretty significant color change, though. But only for filled rectangles. Which is a little odd. So why is that the case? Who's wrong here? I suspect it might be OpenGL, by the way. So OpenGL, when it's drawing, and it disables texture 2D, and it's drawing in a color, but blend should still be on, right? I wonder if the GL colors are getting pre-multiplied automatically. That's a good question. So if we do a GL color for FV, does it pre-multiply that color? Well, no, no. I'm out to lunch there. I was thinking of gamma correction, which has nothing to do with that. But yeah, now that I think about it, so when we're doing gamma correction on these values, I guess I don't know if GL gamma corrects the GL color for FV color that you specify, or if it doesn't gamma correct it. I'm not sure how it interprets the color. You know, when you're in your own shader, it's very clear what that would do because you wrote it out whether it does or it doesn't. But I don't actually know. But anyway, let me take a quick look at render.cpp, and that'd be in draw rectangle. So let's see, draw rectangle. Draw rectangle is copying out the R. Why is it doing that? Yeah, I don't know why it's doing that. So draw rectangle multiplies the color value by 255 to get it into the right space, which seems totally fine. And then let's see, set 1 PS. It doesn't square the color, so the color is not gamma corrected, right? I see no gamma correction here. So I think, if I'm not mistaken, that would probably be the difference, right? So this color value is not modulating anything, and so OpenGL would presumably take whatever that color value is that comes in, and when it writes it out, whatever that color value is, it's going to do the conversion back to... It's going to ungamma correct it to write it to the frame buffer, right? And so I'm not sure what we want to do with that. Let me see if we do. No, we do. Okay. So we square our destar G and B. I'm just not sure how we want to approach this. That's almost certainly the difference between the two of us, right? I would think. Oh, well, I'm wrong. I would have assumed that that was the primary difference, would be whether or not we were gamma correcting our RG and B values. This definitely seems like the kind of thing where having a better handle on exactly what OpenGL is doing would have been nice, right? Like, I'd like to know exactly what it's doing in there, because this looks relatively sane to me. What we're doing is what I would expect. However, I would think that this, I wouldn't have expected them to do this, right? So if you take a look at what I'm doing in that code, I'm squaring our colors, which is gamma correcting the color, basically. I'm doing gamma, de-gamma, blend, re-gamma. And in OpenGL here, you know, I'm specifying this color for FV. I know it's going to de-gamma whatever the results are, because it's, you know, actually I should say we're looking at this path, right? It's going to de-gamma whatever the results are. That's true. But I don't know what it does with the modulation color. I would assume that it doesn't gamma correct them. And so I would assume that the problem here would be that we were gammaing it and they weren't. But that only seems to make things, you know, I guess I wouldn't say worse, but it certainly doesn't help, right? You can see that the color is very dark there. And switching this to not have the gamma correction on the way in, just really doesn't seem to make any difference. And as you can see, all of our bitmap paths are exactly as you would expect. So those are still exactly the same. All right, so let's take a look at the OpenGL code and see if I could figure out what it is that it's actually doing in there. It's calling OpenGL rectangle, and OpenGL rectangle is just setting the color for F with whatever the premol color is. So yeah, I just don't see it. I don't see where we're diverging there. But we obviously are. And, you know, we've got blend on and we've got 1 minus source alpha on, and that's what we would be doing here, right? We're doing our blend with all of our texels, where texels is just a solid color now, right? It's just the dest. Oh, I'm an idiot. This is the frame buffer read. I was thinking of this one here. Yeah, that was dumb. Let's try that one more time. So, squaring the incoming color, this is the alpha correction for the incoming color, right? Not the dest. It's called dest. You'd think I would know that if something was called dest, that it's not the source. But hey, it's been a long day. That is probably the problem. And let me just see here. Not a good sign. Texel R equals mm square. Yeah, so if anything, that made it worse. That suggests that they are, and we just need the 2.2 in order to match, so it's just not enough of a power. Let's check out what happens if we, and this is going to be awful speed-wise, but if we actually do a POW function there, right? So if we just had a better, if we were just closer to the gamma curve, we could take a shot at that and see what it actually was. So, okay. Oh, well, it won't actually, because we can just do it ahead of time. So we have our Texel RGB here, and we're going to take that incoming color, which is the RGB. I don't know why we square that, because the incoming color is not changing, so I don't know why. I guess we must have just copied the source in there, because we probably didn't ever care about doing this one. But all I have to do for that is I can just do, you know, this, and we should be now exactly the same as we were, right? Or not. Is this because of the 255? Color RGB. These are all set from RGB and A. The max color value should be 255 times 255. So the squaring, yeah, of these guys has to be after the times, which is also a little confusing there. Right. So I don't know. It doesn't make a lot of sense to me what's going on here. I gotta be honest. Because that should be, like, all we're doing is doing squaring to render, to do the gamma correction. And if you look, when we toggle, the colors of the bitmaps that are going through the same process hardly change at all. But the colors of solid-filled rectangles are drastically different, right? And so I don't understand what it is about our paths. We've got some very specific deviation from the way OpenGL is processing these colors, but I really just don't know what it is. And you know, if it's not gamma correction, then I could turn off, you know, if it was just that they weren't gamma correcting it, then I would suspect that doing this well, actually, that's actually a little bit interesting, now that I think about it. Hold on one second here. So in here, when we load the destination, we are then squaring the destination, and we're squaring it in 0 to 255 space, which means that the incoming color needs to actually be in squared space, but not gamma corrected, if we wanted it to match OpenGL, which means that the color values would actually all have to be multiplied by 255 again to be in linear space. Does that make sense? I don't know if it does, but I'm talking about this, right? And that's kind of crazy, but that's just what I was thinking, and I wanted to see what it was. Hey, look, that's almost exact. All right, did you guys catch that? That's one of those subtle things. I'm particularly bad at code like this, probably because I was never an old school rendering guy. But did you see what was happening there? We were in 0 to 255 space because that's the most convenient way for us to have done the blending. That's the way we were doing the blending, if that makes sense. So, you know, we have numbers that are between 0 and 255 to do our blending, because we're loading in 8-bit values that are already in there, and we don't want to have to convert them to float for no reason. So we have numbers that are between 0 and 255, but then because of gamma correction, we're squaring those values, right? So that takes it from 0 to 255 to a 0 to 255 squared, right? That's actually the range now of those values. So if we square the values that are coming in for our color, that's fine, because now those values, right, we multiplied them by 255, and then we were squaring them, right? And so that would produce the proper range. So essentially, like, times 255 to go from the 0 to 1 range of the incoming color to the 0 to 255 range, right? That's a times 255. That's fine. But then we need to somehow get to a range between 0 and 255 squared, right? And so the squaring used to do that, but if we don't want to gamma correct, we don't want to square. but we still have to put it into this range. So we need an extra multiply by 255 in order to put us into the same space as the source dest reads that we're doing up from the frame buffer, which is getting gamma corrected, right? Okay, so now we're matching properly. And so I think that definitively answers our question, which is that OpenGL does not gamma correct that value, right? The color value is not gamma corrected at all. It's just a multiply. So basically, you know, like this value. This value right here is never gamma corrected. Just pointing it out. Okay. So now we just have to figure out why we're not setting this value correctly, because obviously we are not setting it correctly. So I need to go into the render group and probably do a little breakpoint action to sort of see what I messed up here, because I obviously messed something up here. All right. So you can see us lerping color values, all each by component. And then we're multiplying by the alpha to give us a pre-multiplied version of the destination, and that's what we're storing. So what we would expect here is we would expect to see these colors affecting our entities as we go through. And here we are in world mode, setting them up, right? You can kind of see them getting set here. When we have the camera in certain ranges, we expect that operation to take place and do its thing, right? And you can see here in the rendering code, right here, we're going through the piece. All of these push bitmap calls should be inheriting this render group information that we set up here. And so the question is, why aren't we seeing anything? It's like these values literally aren't having any effect at all. And that's not what we would expect. We would expect to at least see something happening there. And so we're obviously getting something very wrong. And so I'm going to go ahead and take a look here. Let's tRGB and A, T global color, yeah. So that, I mean, it doesn't look obviously wrong. So what I'm going to do is I'm just going to set a breakpoint in the code for sort of what I suspect will be the most obvious place where I can watch some of that happening. I'm just going to see if I can spot some shenanigans happening in our code that tells us what the bug is. So here we are in fade top, fade bottom. And I'm going to go ahead and look at fade top because that's an alpha fade. And it's the one that's most obviously in our face and wrong. So we should be able to do something about that. So let's take a look at a t-value. We've got a 0.3 t-value here. And so we're setting up the render group in a particular way. Let's see what we're actually getting there. Here is the render group. We've got T global color. We've got that 333333 there in the W component, right? Yeah, that's all good. Let's see here. Global color is all zeros. That's what you would expect. So now we just need to go watch this particular entity actually record something, hopefully, that it wants to draw. And of course, it's not going to. So that's unfortunate. Let's try one more time. Here's a t-value of 0. It's not going to help us. Come on, give us a t-value. Why are these t-values always 0? Probably because this is something that's way out of bounds. Yeah, those are basically all 0, and we need one that's not going to be 0. I could set a breakpoint inside this loop. So what I could do is say if t is greater than 0.1 or something. And now we've got a little handle there we can break on. So now we know that T is going to be something other than that. So let's take a look and see if we can get someone who actually renders something. Of course not. Oh, wait. But draw hit points would, if it had, well, but it won't have any hit points. It's got a traversable, though. Well, this will be fine. I don't know why I was so worried. This will be fine, right? So here's our push rect call. Here's our call to store color. You can see what our T, C, and source are. And here's what our dest will be. So our T value is what we'd expect. It's the 0.333 there. Our C value is 0, which is what we want. Our source value is just some input color, which seems totally plausible. We compute the destination alpha, and the destination's alpha value is, as we would expect, less than what it should be. It's 0.3 of the way towards 0, which is exactly what we would want. We have the dest R, G, and B values, and those are getting blended as just the source times whatever that destination alpha is. So you can see the destination R, G, and B. So let's compare that quickly to the source. I'm going to go ahead and set the source RGB, oops, and the dest RGB, just so we can verify that they are actually different. Yeah, you can kind of see that they definitely did get modulated down. So that dest value does look like a properly source modulated value. The alpha that's coming out in it is obviously, you know, less, and the colors are modulated. We return it and we store it in premul color. So now I'm not quite sure why we're not seeing the alpha fading that we would expect to see on any of these things, right? Because what we're seeing here is we're not seeing any of that fade, right? Right? You can see everything is getting drawn at full opacity, and I'm not sure why, because we are actually passing those pre-multiplied alpha values. So what we would expect to see here is we'd expect to see those things fade out. And I guess I can do, you know, a couple little checks here. You know, I can make certain that we're not doing anything too incredibly stupid, like in the OpenGL renderer, where we do GL color for FV. I could here, for example, just say, well, what would happen if I was to set everything to 50% alpha, right? I should see, oops. I should see everything at half opacity. And if for some reason I don't, then we've got another issue. Who knows what it is, but we've got one. Okay, so that, oh, well, duh. That is not the right one. I want this guy. So in OpenGL rectangle, which is this guy, if I was to take this premul color and multiply it all by 0.5, right, which is when I pass it here, I should see all of those rectangles fade out at half. And I do. So the question is, why is the entry premul color on the rectangle still wrong? Is it something where I forgot one of them in here and we're not calling store color, right? Which seems pretty plausible that we could have forgotten one. All of those are calling store color though. So that's not particularly. Are we clearing that value too soon? Would be the other one. Like down here, we're resetting that for some part of it, right where we set the T global value here. But now that shouldn't have any problem with it. And I guess I can check that like draw hit points or something isn't being weird there. I don't know where draw hit points actually is. There it is. That's totally fine. Shouldn't do anything weird. So something is happening negatively to this when we're calling to render the traversables, but I don't know what it is. And they're both using the entity transform. And they're both using color values that are totally normal. So what's the deal? I'm going to go ahead and set a breakpoint in my OpenGL renderer. Where is my OpenGL renderer? I guess it's not there. Then I'm going to set a breakpoint in OpenGL render commands. So when we come down through here, I kind of just want to see what these entry pre-mill colors tend to look like. Just so I can get a feel for, you know, why are they always the same thing? So the other thing I could do is tag these guys with some additional information. I will say, not seeing a lot of modulated colors there, which is a little bit weird. I don't know, does that seem weird to you? What would be drawing all of those colors? Well, I guess those could be things that are, we draw everything kind of further away first and we draw the top stuff. So it would be a little bit difficult for us to figure out which one those are. Fortunately, I could use a little trick here that would make things a little easier to debug. What I can do is say, all right, when we do a render entry, and this is a trick I use a lot when you don't have good debugging facilities, like basically like if you don't have years of debug code systems and stuff like this to draw on. What you can do is when you have a render group entry, like something like this, you can say that if you're in Handmade internal mode, or like I guess Handmade slow might be the best way to say it. What you can do is you can tag these guys, right? So you can introduce a tag value here, right? That's like debug tag. And then what I can do is I can just specifically say that I want to tag something that goes through the pipe, and I want to see it come out the other end so that I know whether it's doing something weird or not. So what I can do is say, hey, if entry header, or I should say, if entry header like so, if the debug tag equals, you know, whatever number it is, whatever one I'm looking for, then int break here equals true, right? So it's like this is where we can stop. And so what I can do is say, well, when we push that entry on, and if I want to, I can go to, say, let's see here, debug render group.cpp. When we do like a push rect or whatever, the render element that we push on there, we can have that take that tag value, right? So we can do something like say, okay, there's a render group, which is here, and we can always just do a thing that's like debug tag, and whenever we push one of these guys, like let's see here, push render element, we can do a test that says if Handmade slow is on, go ahead and give this guy his group's debug tag. So now, since we're sending so much stuff down the pipe and it's really cumbersome to debug those, what I can do is say, well, whenever I'm going to push down one of those ones that I wanted to look at, right? So, you know, something where I've got the fade value stuff happening here. So someone where I do fade top start, I can do a thing where we go like, oh, the render group's debug tag equals 1 for those. And then when we push stuff on, you know, otherwise we'd set it to 0 or whatever, right? So maybe like down here after we do the push bitmap calls, or I guess we want to debug these guys. These are the ones that are busted, right? So now we're just going to get traversables that have that property in theory. So what I should be able to do now is if I go to opengl.cpp, I should be able to set a breakpoint here, and I should know that the kind of thing that I got was one of these, and it was one of these where I tried to set the pre-multiplied color equal to something that faded out. And you can see that it actually is set to something that's fading out. It's 0.666666 here, right? So the color of this guy actually looks relatively correct. And unfortunately, it does look like a fair number of people who entered that path, though, are still getting kind of clamped out there, or something. And I'm not sure exactly what's happening, because those values don't look very reassuring. Let me take a look here. So when we were taking this, well, so you know what the problem is, I bet, now that I think about it, now that we look at what's actually happening. This value of t in the past was actually, it was a modulating value, so it went the other way, right? So it's probably that those things are close to the camera. They probably would fade out as they got into range and then pop. But it was probably too quick for us to notice that was happening. So that is almost certainly why we're getting those. So we're actually probably doing the correct thing, but we had the t sense flipped, right? And there we go. I gotta fix the hopping code for working on layers properly. Okay, so that's all good now. But now we need to do the other other fade out properly, and that's going to have the same problem, right? This is actually going to want to be 1 minus t. So I think if we should be able to just say, well, if it was going that way, we should be able to make it go the other way, right? Because our clamp map to range should be able to take an inverse range, or and produce the mapping from one to the other correctly. So I think we don't really have to do 1 minus. We should just be able to do that, and now it's correct, right? So that should still be the correct thing here. Yes. Okay. So now we just have to figure what's wrong with our bottom floors. This t value should be going from the bottom start z up to the down to the bottom end z, and so yeah, that t gets higher as it goes, which is what we want, and we should be fading to this global color, but instead we're fading to black, and fading to black doesn't make much sense. So I'm not sure why we're getting that fade. Let's just quickly verify that there's nothing else wrong here. I don't see any lower values at all. Which does not fill me with confidence. I guess I'll make sure that isn't, because that's in the platform reloadable code, so that should have been fine. So we have some other fun bug there. But I don't know what it is. So let's see. If we've got 0.5, 0.5, 0.5. If we've turned off the T global color entirely, we should see no modification whatsoever. So why are we seeing a modification? I am not sure. Because this should be indistinguishable from the regular case. And so it shouldn't really be affecting their colors at all, I should think. And the way that this is specified, let's see here. The way that this is specified, if the T values are 0, there should be no change to the source color. So all it should do is pre-multiply the source color, the source alpha, or rather the source color by the source alpha, which is what we always wanted to do anyway. And so that shouldn't have any deleterious effects. So why are we not seeing anything below that first level there? Oh, that's just the clear. Oh, right, because there isn't anything below that level. That's just actually clearing the global color value affecting our clear. That's actually what's going on there. So that's actually fine. Okay, so now that we've got sort of a view down, let's go ahead and turn on the correct blending here. So there we go, and you can see it kind of blending out to sort of a gray color there. And I don't know what we actually want it to blend out to. I'm not sure, but we probably want to clear the screen to the same color that we're fading out to. Like I said, I'm really not 100% sure what we want to do there. So when we do our clear, which is happening here, we need to set the dest alpha to 1 so that we'll get that sort of haze effect there, right? That might be a little bit too bright for haze. I don't know. That maybe looks a little bit better. But I'm going to want to have sort of a background color that we specify here. Because I'm going to want that to be the thing that we fade towards whenever we modify it. Yeah. So now we're sort of getting that haze happening, and now you'll notice that those are not transparent anymore, right, either. So kind of as that fades off into the distance there, it's pretty satisfying, right? You can kind of see it happening back down in there. And that's about right. Okay. So I'm pretty happy with all of that. That seems reasonable. Totes reasonable. So I will go to some Q&A. One thing you could try is having the center of the perspective projection be the player's position, so other things on other levels line up straight. Well, they would only line up straight with wherever the player was standing, though. They wouldn't. So as you moved, the levels behind you would move, which doesn't sound good to me at all. Soy Sauce the Kid. The Hadamard transform seems like it could be used for a lot of other things. What is it doing in handmade world.cpp in the subtract function? Well, I'm assuming it's just scaling the values by a non-uniform scale. So, I mean, I don't know, I'll go look, but that's probably the wrong thing. But the Hadamard product is sort of a diagonal matrix. And let me tell you what I mean by that. So let's suppose that we were going to take a vector and we wanted to scale the vector. And we do this on Handmade Hero all the time, right? So I've got a vector, you know, and it's pointing in some direction. And I want it to be longer or shorter, but in the same direction, right? And so maybe I've got a scale value, right? And my scale value is C, let's say. And so I'm going to take whatever this vector is, V, and I want to produce a new vector. So I do V prime equals C times V, okay? So if C is, say, for example, 2, then V prime is 2V. I have a vector that's twice as long as my original vector was for my new vector, right? But now suppose that I want to scale scale this vector in a way that makes it twice as long along X, but no longer along Y. So it's going to be exactly the same height, but it's going to sort of skew out that way, right? Well, you know, in 3D graphics, we're very familiar with doing non-uniform scales as matrices, right? Because in this equation, right, what we have is something like, well, my V prime is like V prime X, V prime Y, you know, as a vector, 2 components in the vector, equals C, which is a scalar, times Vx and Vy. And we know that that just kind of distributes inside, so we can just do CVx, CVy, and so, you know, we have V prime X equals CVx and V prime Y equals CVy. But what if we don't want these to be treated the same, right? What if we want something more complicated here? Well, we know we can introduce sort of an arbitrary linear transform by just using a matrix here. And so what I can do is I can make this a matrix equation. Well, it's already a matrix equation, but I can make it more of a matrix equation, if that means anything, by having a scaling in X, a scaling in Y, and multiplying my vector times that, right? That makes sense? Now I'm going to write this in the more convenient way for multiplication, where I write the Vx, Vy up here, so you can kind of see how it works, right? But matrix multiplication, I taught you how to do that a long time ago on Handmade Hero. You just take the row and the column and you multiply them component-wise together. So Cx times Vx, 0 times Vy, which of course is nothing. And then we do it, same thing again here, right? 0 times Vx, which is nothing, Cy times Vy. And hey, I got what I wanted, a Cy and a Cx, right? So I scaled non-uniformly by using this, which is a non-uniform scaling matrix. Right? So this is my non-uniform scaling matrix. You would recognize it from computer graphics. If it was a 3D one, it would have 3 components. If it was homogeneous, it would have 4. It would have a 1 down here, Cx, Cy, Cz. And everywhere else it's 0. We're very familiar with this, and you know rotation matrices, they have all 4 of them filled in, blah, 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 right? Well, if you look at what that's actually doing, that's basically taking the Hadamard product of the diagonal of this matrix with the input vector. So in some sense, the Hadamard product is just a way to write a diagonal matrix as if it was a vector. It's a way to write a diagonal vector, which doesn't really exist in the real world of math, right? So one way I could look at the Hadamard product is to say that if I was to take a vector and do the like diagonal operator on this thing and produce the matrix that has that vector along its diagonal, well, that's this, and then multiply it by something, right? That's the same as taking the Hadamard product with that vector. So, you know, yeah, does the Hadamard product have uses? Sure. They're basically uses where a diagonal matrix would have been what you would do. And the reason that it's not that common is usually just because there's not that many times that you want to use just a diagonal matrix. But there are enough, and that's why it shows up in the code. Huber Caleb, for the record, a circle with an X would be the tensor product. I don't think that's true. My recollection is that the thing that I drew, which I always draw, is some operator. Right? Like, generally, every book that I've ever known that introduces an arbitrary operator uses that. So I don't think that this means anything in particular. I think it means something that we were doing in this branch of mathematics right now, but I could be wrong about that. So yeah, has it probably been used to write the tensor product? I bet. But is it mean that? I don't know. It probably means a lot of things, would be my guess. And you'd have to just tell by the context. JP2, would it be difficult to implement textured or just different fog colors so you could make, for instance, vignetted fog? Well, it's not difficult to do this, but it's not something that we would probably do in quite the same way. And the reason that I say that is because, so the reason that we're able to sort of take a shortcut here, and if you take a look, you know, in render group, so here's the store color code, and this store color code does all of that work. Right, just these few lines of code, that's it. And it only runs once at push time. But if you wanted the code to do something where you were modulating with, or I shouldn't say modulating, fading to colors that are changing, then we would need to make that be something that happens out in the actual renderer, right? So what we would have to do is, rather than just setting a single color here, we would have to set up a second texture unit, or a shader that had some procedural something in it, right? Like for vignetting, we wouldn't really need a texture, right? We could do that procedurally if we wanted to. And then when we would set this value, instead of setting this as the color that just is straight up used as a modulation against the incoming texture, what we would actually be doing is specifying what we wanted the blending coefficients to be to this magical other texture that we have that does, and that operation would have to be done per pixel by the graphics card, right? So it's not particularly hard to do, but it's definitely, you're adding one additional layer of complexity on top of what you have here, which is to say that rather than just tweaking a color once, you have to set up another source of screen space data to pull from before you could get that to happen. How did you finally discover the gamma correction bug? What was the clue that made you say, aha? Well, I'm sorry, was it, I mean, you watched me do it, right? So you saw all the steps. I'm not sure that there's anything that makes you say aha. It's just, as with any subtle like thing like that where there's just a lot of steps involved, you have a certain preconceived notion of what's going on, and you forget some of the little details, like the fact that the range is squared when you write in that routine. And so when I tested it by turning off the gamma and didn't see the right result, I was like, huh, that's weird, I don't know what's going on. But I knew that something was wrong because I'm like, one of these two should match and neither matches. So then I know I have to investigate further. And when I sort of figured out the range thing, then I was like, oh, okay, let me try it with the right range, no gamma correction. I was like, okay, there we go. And so I don't think there was really a single aha. It's a series of steps where you narrow down the like possibilities of what could be wrong until you're left with something staring you in the face and you go, oh, that's the one. All right. I am going to wind it down. All right, so that's good. So that's like a more consistent thing. And so tomorrow I think we could maybe start on trying to, I'd like to tomorrow get into the specifying Z for hover versus Z for sheeting. So I think that'll put us in good shape for tomorrow. Let's go to the web browser. There we go. Thank you, everyone. Thank you, everyone. Good, I can talk. It's real easy. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you could always pre-order the game, which comes with the source code, so you can play around at home with the source code. Why am I gotta go to bed. Anyway, play around with the source code and experiment with it and learn from it and all those other good things. You can also go to our forums if you want to ask questions about the series. We can, basically what that amounts to is sending up a bat signal to Martin's Mosaico, who somehow manages to answer everyone's question on every single Handmade Hero forum, and he seems to somehow know what is wrong with everyone's code. It's pretty amazing. You should see it sometime. We also have a Patreon site if you want to support the video series. We have a schedule bot where we tweet the schedule if you want to catch the episodes live, like tonight. And then we also have an episode guide you can go to if you want to catch up with episodes that you missed, past stuff, if you're curious how something was happening. That's the place to go. That's it for today. I will see you back here tomorrow for the last stream of the week. No, second to last stream. We got one Wednesday and Thursday. So for Wednesday's stream, Thursday's the last stream of the week. Same time, same place, 8 p.m. Pacific Daylight Time. Hope to see you all here. Until then, have fun programming, and I will see you guys on the internet.